Hi everyone, in this video I'm going to continue from where I left off. So in the previous video I discussed the factor theorem and remainder theorem, and we did a number of examples. So if you haven't watched that video, be sure to check out that video, and I'll provide a link to that video in the description below. Okay, so I'm going to try a more challenging problem in this video. So before I attempt that problem, here's a couple of notes. So the first note is, whenever you see the words factor of, divisible by, or exactly divisible by, so either of these three terms, they all mean that the remainder is equal to 0 upon division. Okay, so have it in your mind, factor of divisible by, so not divided by, divisible by, or exactly divisible by, they all mean that the remainder upon division is 0. Okay, so let's try this problem using our knowledge of the remainder theorem. So in example 2, so we have a polynomial 2x cubed plus ax squared plus bx plus 6. That gives a remainder of 12 when divided by the linear x plus 1, and a remainder of minus 6 when divided by the linear x minus 1. So the remainder of 12 is when you divide the polynomial by x plus 1, so bear that in mind. The remainder of minus 6 is the remainder when divided by x minus 1. The first part to this problem is to find the values of a and b, and the next part hence factorize the expression. Okay, so let me show you how this is done. So the idea of this problem is we need to create two equations in terms of a and b, and we can create the two equations using the remainder theorem. So let me use the remainder theorem to find an equation in terms of a and b when the polynomial is divided by x plus 1, and remember the value of the remainder is 12. So back to the paper and pen. So let's go through the remainder theorem steps to create the first equation. So in the remainder theorem, f of x is the polynomial. The polynomial is 2x cubed plus ax squared plus bx plus 6. And the linear is x plus 1. Remember, in the remainder theorem, we always equate to 0, the linear. If I take the plus 1 to the right hand side, x is minus 1. And this takes us to step 2 of the remainder theorem. So if we go back to the screenshot, once we calculate the remainder, the value of the remainder is given for division upon x plus 1. The value of the remainder is 12. So if we go back to the paper and pen, let's find this remainder. So the remainder, and we'll call the first remainder R1. So R1 will be f of the value of x in step 1, which is minus 1. So if I replace all of the x's here by minus 1's, we're going to have 2 into x, which is minus 1 cubed, plus the a, x, which is minus 1 squared, plus the b, x, which is minus 1, plus the 6 at the end. Okay, so in this case, when we multiply out, so let's multiply out, minus 1 cubed is minus 1, times 2 is minus 2, minus 1 squared is plus 1, times a is plus a, minus 1 into b is minus b, plus the 6 at the end. And I would say simplify to the maximum. So in this case, if I add minus 2 to plus 6, minus 2 plus 6 is plus 4. So we're going to have a minus b plus 4. So this is R1, the first remainder so far. So if we go back to the question, remember the remainder upon division of x plus 1 is 12. So R1 is 12. So if we go back to the paper and pen, since R1 is equal to 12, if I replace R1 by 12, I'll have a minus b plus 4 is equal to 12. And if I take the plus 4 to the opposite side, my first equation is a minus b is equal to 8. So I'm going to call that equation number 1. So let's go back to the screenshot. So in this case, in the screenshot, the question continues by saying that the polynomial gives a remainder of minus 6 when divided by x minus 1. Okay, so let's repeat similar steps to find another equation in terms of a and b for when this polynomial is divided by x minus 1 and bearing in mind the remainder is minus 6. So back to the paper and pen. So step number 1 of the remainder theorem, f of x is the polynomial. So the polynomial reads 2x cubed plus ax squared plus bx plus 6. And the linear is x minus 1. Equate the linear to 0 when it comes to the remainder theorem. So if I therefore take the minus 1 to the opposite side, x therefore is plus 1. So this takes us to step 2 of the remainder theorem. And let's call this remainder that we're calculating R2. So R2 is the remainder to the second part of the problem. So R2 will be f of the value of x in step 1, which is 1. So if I therefore replace the x's in f of x by 1's, we're going to have 2 into x, which is 1 cubed, plus a into x, which is 1 squared, plus the b, x, which is 1 plus 6 at the end. Okay, so let's multiply these brackets. So 1 cubed is 1 times 2 is 2. 1 squared is 1 times a is a. B times 1 is a b plus a 6 at the end. And if I add the 2 to the 6, 2 plus 6 is 8 plus a plus b. So this is R2 in terms of a and b. Okay, so if we go back to the screenshot, we have the value of the remainder, bearing in mind the value upon division of x minus 1 is minus 6. So if we go back to the paper and pen, so in this case, since and R2 is minus 6, if I replace R2 by minus 6, we're going to have minus 6, that is 8 plus a plus b. And if I rearrange, my second equation is a plus b, taking the 8 to the left hand side is minus 14. Let me call that equation number 2. So if we go back to the question, the first part of the problem is to find the values of a and b. Okay, so if we go back to the paper and pen, now I have 2 equations. So here is equation number 1. So a minus b is 8. So equation number 1. And here is my equation number 2. A plus b is minus 14. Okay, so let me write down the 2 equations. So equation number 1 is a minus b is equal to 8. That's number 1. Equation 2 is a plus b is minus 14. So that's number 2. Okay, so we can solve these equations. So if I add them, so by adding I can eliminate b. So minus b plus b will be eliminated through addition. A plus a then is 2a. That is equal to, on the right hand side, 8 plus minus 14 is minus 6. I make a then minus 3. So that should be the value of a. If I put the a value into either equation 1 or equation 2, so if I put a is equal to 3, say, into equation, so I'm going to choose equation 1, we're going to have a, which is minus 3, okay, minus b, that is equal to 8, if I put it into number 1, okay. So if I take the minus 3 to the opposite side, minus b will be 8 plus the 3, which is 11. So if I multiply both sides by minus 1, b is minus 11. So just to summarise, the a value is minus 3, the b value is minus 11. Now, if we go back to the screenshot, there is another part to this problem, hence factorise the expression. Okay, so let me show you the method in order to factorise the expression, meaning the polynomial. So if we go back to the paper and pen, so we have our values of a and b here. So the first thing that we need to do is, let me replace the a and b in our polynomial for f of x. Okay, so if I put in the values of a and b that we calculated, so our f of x is going to be, as a result, 2x cubed, so 2x cubed, plus ax squared, a is minus 3, so minus 3x squared, plus bx, b is minus 11, so minus 11x, plus 6 at the end. Okay, so now we have this polynomial for f of x with a and b included. Now the question, remember, is to factorise this expression. Factorise this expression means we need to take this polynomial and express it as a product of 3 terms. Okay, so in particular we're going to express this polynomial, or this cubic polynomial, in the form of a product of 3 linear factors. Okay, so let me show you the method. Now, to factorise this expression, here's the method. So let me show you the method to factorise the expression. So let me break down the method in the form of steps. So here is step number 1. So in step number 1, we need to use the factor theorem to find a factor of our polynomial f of x. Okay, so remember the idea of the factor theorem. If we calculate f of a certain value a, and if f of that value a is equal to 0, the idea is that x minus that value is a factor of your polynomial f of x. Now my trick is, look at the constant term in f of x and try factors of that term. So try positive and negative factors of that constant term in f of x, and you may discover that one of them, when you calculate f of that value, will give you 0. Okay, so I'm going to try this approach. So let me show you how this approach works. So let me try xa as 2. So remember, 2 is a factor of 6. Okay, so if I calculate f of 2, let's see whether the answer is going to be 0. So if I replace all of these x's by 2's, I'm going to have 2 into x, which is 2, so 2 cubed, minus the 3, so minus the 3, x, which is 2, so 2 squared, minus the 11, so minus the 11, x, which is 2, plus the 6 at the end. Okay, and by calculating f of 2, the answer, I can tell you, is not 0. That means x minus 2, or x minus the value that we tried, is not a factor. So remember what I said, you can try positive or negative factors of plus 6. Okay, so now I'm going to try x is minus 2. So minus 2 is a factor of plus 6. So if I calculate f of minus 2, okay, so let's keep our fingers crossed. So if I replace x's in f of x by minus 2's, I'll get 2 into x, which is minus 2 cubed, minus 3 into x, which is minus 2 squared, minus the 11, x being minus 2, plus the 6 at the end. Okay? And if you calculate this, you're going to get a value which is 0. Okay? So f of minus 2 gives you a value of 0. So from the factor theorem, if f of a is 0, x minus a is a factor. So in our case, f of minus 2 is 0. So x minus of minus 2 is a factor of the polynomial. So in this case, x minus of minus 2 is x plus 2 is a factor. Okay? The idea of step 1 is to find a factor of your polynomial f of x. So that is step number 1. Okay? Now once you've found your factor, you go to step number 2. Step number 2 is to algebraically divide your polynomial by the factor that you found in step 1. Okay? So let me take this green pen again to write down the step. So now we algebraically divide, okay, f of x, the polynomial, by factor in step 1. Whatever you have as your factor in step 1, divide f of x by that factor. So remember the first video that I did on algebraic division. So that video explains the process of algebraic division. So if you haven't watched that video, be sure to check out that video. I'll leave a link to the video in the description below. However, let me go through the algebraic division process. So we're going to algebraically divide using bus stop. The polynomial is 2x cubed. So 2x cubed minus 3x squared minus 11x plus 6. So we're going to algebraically divide this polynomial here, okay, by the factor which is x plus 2. Okay? So remember, in that video on algebraic division, when you divide in the order DMS. DMS means divide, multiply, then subtract. So let's divide first. So we need to divide the highest power term in your dividend by the highest power term in your divisor. So 2x cubed divided by x is 2x squared. So whenever you divide, write the outcome on the top of your bus stop. Then it's m is multiply. So now we multiply 2x squared by both x plus 2. So 2x squared times x is 2x cubed. So whenever you multiply, put the outcome underneath the corresponding powered terms of your dividend. Okay? So let's continue. 2x squared times 2 is 4x squared. Okay? So multiplication is complete. Let's do s. S is subtract. So remember the idea of subtraction. Reverse the signs of the bottom two terms. So this plus reverses to minus. This plus reverses to minus. So that when I add, 2x cubed minus 2x cubed is nothing. Minus 3x squared minus 4x squared minus 7x squared. Okay? Ideally, we need two terms here. Let me go to the term above and bring that next term down. So I'm bringing down the next term above down, which is minus 11x. And then we repeat the process. So we go back to division. So now we divide the first term here, minus 7x squared, by the first term here, x. Minus 7x squared divided by x is minus 7x. So whenever you divide, put the outcome on top of your bus stop. Next operation is multiply. So now we multiply minus 7x by x plus 2. Minus 7x times x is minus 7x squared. Minus 7x times plus 2 is minus 14x. Okay? So let's get ready for the next operation, and the next operation is S, subtract. So let's reverse the signs of these bottom terms. That minus reverses to plus, that minus reverses to plus also. Minus 7x squared plus 7x squared will cancel. Minus 11x plus 14x is plus 3x. Okay, so ideally you need two terms over here. So let's go to the term above, carry that down along with the sign. So let me bring down the plus 6. Okay, now we repeat the process. So we go back to D. D is divide. So let's divide 3x by x. 3x divided by x is plus 3. So put the outcome of division on the top. Then we go to m. M is multiply. 3 times x is 3x. 3 times 2 is plus 6. Okay, so let's get ready for the next operation. Next operation is subtract. So change or reverse the bottom two term signs. So this plus reverses to minus. This plus also reverses to minus. When you add, the remainder is going to be 0, and it should be 0. So it should be 0 upon division, because think about it, you're dividing by a factor, and if you're dividing by a factor, remember the notes that I made in one of the screenshots. So let's go back to that screenshot. So if you're divided by a factor, factor means the remainder is 0. Okay, so if we come back to the paper and pen, our remainder is 0. So we can reassure ourselves that the process is correct. So you can also do a double check. Okay, and this takes us to the next step. So here is the next step. So let me continue over here. The next step and the last step is step number 3. Step number 3 is to use this relation that I explained in the first video on algebraic division. So remember this relation, the dividend is always the divisor multiplied by the quotient plus the remainder. Okay, so again, if you haven't watched the first video on algebraic division, I'll provide a link to that video in the description below. So if we go back to the process of algebraic division, remember this term underneath your division sign is your dividend. So the polynomial is our dividend. So let's copy that down. So let me keep that over here so that we can refer to it. So the polynomial is our dividend, which is 2x cubed minus 3x squared minus 11x plus 6. So that is the same as the divisor is x plus 2 multiplied by the quotient, which is 2x squared minus 7x plus 3. So the term on top of the bus stop is your quotient. This is your divisor, this being your dividend, plus, and the remainder. So remember what I noted earlier, the remainder is 0 as you're dividing by a factor. So the remainder should be 0. So let's add the 0. Okay. So let me continue. So since we've got 0 remainder, it's simply x plus 2 into 2x squared minus 7x plus 3. Currently we got 2 brackets. So now the idea is we need to factorize this quadratic and factorize it so that we have an additional bracket. Yeah. So we have x plus 2 from here, and if I factorize this quadratic here, the factors are 2x minus 1 and x minus 3. So that completes this example, and that explains the method in particular of how we factorize the expression into 3 brackets. Okay. So that ends this example, and that sadly ends this video. I hope you found this video helpful. I hope you enjoyed the video. If you did enjoy the video, a like will be very much appreciated. Do plenty of practice related problems, and I hope to see you again.